When researching motor control applications, it's important to utilize a variety of resources to gain a comprehensive understanding. Academic websites offer access to research papers and technical details. Industry websites provide information on current standards, applications, and training. Research institutes and universities often have specialized laboratories and centers dedicated to motor control and power systems. Let's explore some specific websites that can be helpful. Firstly, consider IEE Explore, available at /. This is a resource for accessing conference proceedings, journal articles, and technical papers all related to motor control applications. IEE Explore is a valuable tool for staying up to date with the latest research and advancements in the field. Secondly, Science Direct, accessible through /, is a large collection of scientific journals. This website covers various aspects of motor control. Science Direct allows you to delve into specific topics and find in-depth analysis. Thirdly, Springer Link, located at / provides a repository of books, articles, and conference proceedings. These resources cover electrical engineering and automation, including motor control. Springer Link is particularly useful for gaining a broader perspective and understanding the theoretical foundations of motor control. Fourthly, MDPI, which can be found at /, is an open access publisher. They have a collection of journals focused on automation and control. The open access nature of MDPI makes research readily available. Now let's move on to industry-specific resources. Firstly, the National Electrical Manufacturers Association, or NEMA, offers resources on motor standards, applications, and training. Their website is /. NEMA standards are essential for ensuring safety and interoperability in motor control systems. Secondly, Motor and Drives magazine, found at / is an industry publication. This publication covers motor control technologies and applications. Motor and Drives magazine keeps you informed about the latest products and trends in the motor control industry. Thirdly, Siemens Energy ACTA is a leading manufacturer of motors, drives, and industrial automation systems. Their website provides information on their products and services. You can gain insights into real-world applications of motor control technology. Fourthly, ABB, accessible at / is a global leader in power and automation technologies. Their expertise extends to motor control. ABB website showcases the comprehensive solutions and innovations in the field. Fifthly, Mitsubishi Electric, found at / offers a wide range of industrial automation products. This includes motors and drives. Exploring Mitsubishi Electric's offerings can help you understand the diversity of available technologies. For research institutions, firstly, consider the Center for Advanced Power Systems, or CAPS, at the University of California, Davis, located at / This research center specializes in motor control and power systems. CAPS is a good place to learn about cutting-edge research. Secondly, the Electric Drives and Power Electronics Laboratory, or EDPEL, at the University of California, Los Angeles, can be found at / This research laboratory focuses on motor control and power electronics. EDPEL provides insights into advanced motor control techniques and technologies. In addition to these specific resources, remember to check out the Institute of Electrical and Electronics Engineers, or IEE, at / This is a professional organization with a large community of motor control experts. IEE offers numerous resources and opportunities for professional development. When using these resources, consider a few key areas within motor control applications. These include motor starters, which are devices used to start and stop motors, providing overload protection. There are several types of motor starters, including direct online, reduced voltage, and solid-state starters. Direct online starters connect the motor directly to the power supply. Reduced voltage starters reduce the voltage during start up to limit inrush current. Solid-state starters use electronic components to control the motor's voltage and current. Another important area is variable frequency drives, often referred to as VFD. VFD control the speed of an alternating current, or AC motor by varying the frequency of the power supplied to the motor. This allows for precise speed control and energy savings. Programmable logic controllers, or PLCs, are also critical components. PLC are used to automate motor control systems. They can be programmed to perform a variety of tasks such as starting and stopping motors, monitoring system parameters, and responding to fault conditions. Human-machine interfaces, or HMIs, provide a user interface for monitoring and controlling motor control systems. HMI can display system status, allow operators to adjust settings, and provide diagnostic information. Protection devices are essential for ensuring the safe operation of motor control systems. These devices include circuit breakers, fuses, and overload relays. They protect motors from damage caused by overcurrents, short circuits, and other fault conditions. Communication protocols are used to network motor control systems. Common communication protocols include Modbus, Ethernet, and Profibus. Networking allows for centralized monitoring and control of multiple motors and systems. When researching motor control applications, it's also important to understand the relevant electrical codes and standards. In the United States, the National Electrical Code, or NEC, provides guidelines for the safe installation and operation of electrical equipment, including motor control systems. Article 430 of the NEC covers motors, motor circuits, and controllers. It provides requirements for motor overcurrent protection, motor disconnecting means, motor control circuits, and motor overload protection. Understanding these requirements is essential for ensuring compliance and safety. For example, NEC Section 430.22 addresses the ampacity of conductors. It specifies the minimum ampacity of conductors supplying a single motor. This is typically 125% of the motor's full load current rating. NEC Section 430.52 covers motor overcurrent protection. It specifies the maximum rating or setting of motor overcurrent protective devices. This depends on the type of motor and the type of overcurrent protection used. NEC Section 430.110 addresses the rating of disconnecting means. It specifies the minimum ampacity of the disconnecting means for a motor circuit. This must be at least 115% of the motor's full load current rating. NEC Section 430.32 covers motor overload protection. It specifies the requirements for motor overload protection devices. These devices protect motors from damage caused by prolonged overloads. In addition to the NEC, other relevant standards include those developed by NEMA and IEE. NEMA standards cover the performance and construction of motors and motor control equipment. IEE standards cover various aspects of electrical engineering, including motor control. It's also important to consider energy efficiency when designing and operating motor control systems. Energy-efficient motors and variable frequency drives can significantly reduce energy consumption and operating costs. Conduct regular maintenance on motor control systems to ensure their proper operation and longevity. This includes inspecting motors, starters, and other components for wear and damage. Also, be sure to lubricate motor bearings regularly and replace worn parts promptly. When troubleshooting motor control systems, it's important to have a systematic approach. Start by checking the power supply, control circuits, and motor connections. Use a multimeter to measure voltages and currents. Consult the motor control system's documentation for troubleshooting tips and diagrams. Remember to always follow proper safety procedures when working with electrical equipment. Wear appropriate personal protective equipment, or PPE, and energize circuits before working on them. Only qualified personnel should perform electrical work. Understanding motor control applications requires a combination of theoretical knowledge and practical experience. By utilizing the resources discussed and focusing on key areas such as motor starters, variable frequency drives, and protection devices, you can develop a solid foundation in this important field. Continuous learning and staying up to date with the latest technologies are essential for success in motor control.